Hello guys, myself Dr. Swapnil Shinde, and we are here back with one of the fresh topic from linear algebra, which is the system of a linear equation. Okay, so underneath of system of linear equation, guys, we are going to learn how to find the solution of the variable. Okay, so till the moment you all have learned how to find the solution of equations, linear equation, by using Cramer's rule, or you are in simple, other than matrix there are so many methods that you can find out the solution for equations. Okay, but right now as we are looking for linear algebra, so we mostly apply matrix methods, okay, for finding the solution of a linear equations. For finding the solution for a linear equation in a two variable, it is way easier, that already you all are familiar with. Okay, but from now onward, guys, we are going to learn for a solution of a variable in a solution of equation, a linear solution of equation in a three variable or more than three variable. Okay, so see that straightforward calculations are quite easier to deal this linear equations. Okay, so in such a case, we have to apply matrix method so that easily you can get the solution for matrix. Okay, so let's do it. First of all, I'll explain to you all what is the system of linear equation and how it look like, how can we convert it to the matrix, and further subsequent topic we will learn. Okay, so without further ado, guys, let's get started today's lecture. So guys, we are having here system of a linear equation. Okay, system of a linear equation in n unknown variable. Unknown variable means x1 is unknown variable, x2 is unknown variable, and xn is unknown variable. Okay, a11, a12, a1n, and b1, these are the constant, okay, which present in our matrix. Okay, by using this constant we go for the formation of a matrix. Okay, yes, so see that, guys, these are the n equation in a n variable. So if you follow straightforward calculation, it is quite difficult to find out the solution for this x1, x2, and xn. Okay, it is quite challenging. So in this case, guys, we have to apply matrix method. Okay, like mostly we convert this matrix in the form of Ax, which is equal to b. Okay, the system can be written as, let me write, okay, d above system can be written as Ax, which is equal to b form. Okay, x which is equal to b form, so that you all are already familiar. Okay, we can convert easily this system into the form of x which is equal to b. Okay, so what is the a is the coefficient for x1, x2, and xn in entire variables. Okay, b is the right hand side, b1, b2, bn. Okay, and x is the unknown variable, x1, x2, xn. Okay, where, okay, let me define what are the variables where a can be written as, okay, a11, a12, a1n. Okay, a21, a22, a2n. Write down their coefficient only. a11, a12, a1n, a21, a22, a2n, up to am1, am2, up to amn. Okay, this is the matrix that I have written. How I have written, guys? This is just the conversion of linear equation into the matrix form. Okay, so you can see the coefficient for x1, x2, x3. Just copy it here. Okay, yes. What is the x? What is the value for x? Let me write the value for x. X can be all unknown variable. Okay, okay, x1, x2, xn. These are the variable, x1, x2, up to xn. These are the variable for x. Okay, so I'm having the matrix A, I'm having the unknown as a x. Okay, matrix A and unknown as a x. Okay, yes. So make sure that you supposed to write the matrix in a such a way that once you multiply a to x, we want this linear equation back again. Okay, so see that how I'm going to write a11. How to write the matrix multiplication? a11 into x1 plus a12 into x2 plus a1 into xn. Okay, see that we got the left hand side. Okay, and we have remained with the matrix b. Okay, so how can we write matrix b? B is the right side. Okay, right side for us. So what is here? b1, b2, bn, b1, B2 up to Bm. This is the right hand side for our matrix. Okay, see that this is a square matrix. Okay, n by n, m by n. Okay, this is the single column matrix where n row and single column, that means 1 by n order, and here a single column and n row, m row, so 1 by m order. Okay, so see that. So if you multiply this matrix to each other, we want this linear equation back again. So make sure that, so build the matrix such a way that you can get the original equation back. So if you want to verify, you can check it again. A11 into x1 plus a12 into x2 plus a1 into xn, which is equal to b1. So I got the first one. Similarly, do it for second, third, and up to the nth row. Okay, this is the possible way that you can define. Okay, I hope you all have understood how to convert given matrix in the form of Ax, which is equal to b. Okay, yes, now we have to define. Okay, so mostly we call A as the coefficient matrix because all are the coefficient from linear equation. That's why we call A as the coefficient matrix. Coefficient matrix. This one A is the coefficient matrix. Okay, yes. Now we have to define augmented matrix. Might be augmented matrix is the new concept for you all. See it carefully how it look like. Okay, it is very easy. Okay, I'll define here augmented matrix. U G M E N T E D. Okay, U G M E N T E D, augmented matrix. This one is augmented matrix. Okay, yes, now see that this one is the augmented matrix. So what we do, we convert given Ax, which is equal to b, into the augmented matrix. Okay, and augmented matrix can be written in the form of matrix form A over B. Okay, this one is the augmented form of a given matrix. Okay, augmented form of a given matrix. Now let me convert this A and B into the augmented matrix. Okay, it is way easier, guys, very easy. Okay, but need to see it very carefully. Okay, so let's write A matrix first. Okay, A matrix is A11, A12, A1n, A11, A12 up to A1n, A21, A22 up to A2n. Okay, up to AM1, AM2 up to AMN. Okay, over. Okay, so you don't have to complete this square bracket. Okay, keep that square bracket open. So we are adding this straight line between here. Okay, so we are, what actually we are doing here, we are trying to combine A and B matrix together. Okay, so A matrix I have written here, and then combine slash matrix B, B1, B2, Bm. Okay, so B1, B2 up to Bm. This is the augmented matrix, conversion of a linear equation into the augmented matrix. Okay, yes. So make sure that, guys, this equation should be linear. That means their power x1 to the power 1, x2 to the power xn to the power 1. That means all variable or unknowns should have power 1. Okay, then only you can apply this one. Okay, so augmented matrix can be written as, this is A over B. Okay, I hope you all have understood how the augmented matrix look like. Okay, yes. So after this, we want the homogeneous form of matrix and a non-homogeneous form of matrix. Okay, that one we go for it. So here we want the two definitions: system of homogeneous equation and a system of a non-homogeneous equation. Okay, the definitions are very easy. Just see it carefully. Okay, I'll explain to you all first of all system of homogeneous equation. What is the meaning of system of homogeneous equation? Okay, yes. So we are looking for the form X, which is equal to B. Okay, so only within that we are going to learn. Okay, system of homogeneous equation. Okay, so the system of the form Ax, which is equal to B. Okay, the system of X of the form X, which is equal to B, where B, which is equal to Z. Okay, B I consider another matrix as a Z. Okay, B as a matrix Z with Z is a null matrix. What is mean by null matrix? The matrix where all entries are 0. So we call Z as a null matrix then. Okay, see that we have X which is equal to B, where B which is equal to Z, and Z is a null matrix. Okay, that means X which is equal to null matrix, then we say that system of homogeneous equation. Okay, system of homogeneous equation. Okay, that means we have B as a null matrix here. Okay, yes, similarly go for the opposite direction. Okay, we have X which is equal to B as a non-homogeneous system, but B which is equal to Z, but Z is not null matrix then. Okay, yes, we write a simple form X which is equal to B, which is a non-homogeneous equation. Okay, but where B which is equal to Z and Z not equal to null matrix. Z not equal to null matrix. Okay, so see that this one is the system of homogeneous equation, system of non-homogeneous equation. I hope you all have understood the definition for homogeneous and a non-homogeneous equation. Okay, so guys, we are going to look a system of a homogeneous equation, non-homogeneous equation in detail, okay, in our subsequent lectures. So that is here for our today's lecture, system of a linear equation. I hope you all have understood entire part of from my today's lecture. So if you want, you can take the notes or note of these my notes. Okay, and let me know guys how my lectures are looking to you all, whether it is easy or maybe anything difficult for you all. Let me know in my comment section. Okay, I want the comment from each and everyone here down here in my comment section. Okay, how you feel my lectures. So that's it here for my today's lecture guys. I hope you all have understood everything. Even after, if you found anything difficult guys, let me know in comment section. Okay, so that's it here for today's lecture. Thank you everyone. Thank you for my today's lecture.